Welcome. In this lecture, we're going to talk about a theorem called the intermediate value theorem, which is going to tell you with continuous functions, basically you can't skip values, which is often how we explain a continuous function, like you don't pick up your pencil when you draw it. But that's like really what this is you don't skip values. Okay, so here it goes. So, this is the intermediate value theorem. Intermediate value theorem. This is funny. This one's a little bit. Okay. So what it's going to tell me is, so if, now let's just kind of set it up. So I have that f is going to be a continuous function on, so f is continuous, and this is going to be on the interval AB. Oh, I don't know why usually I leave them off, and then for some reason wanting to put them back on the interval AB. And I have that, so I have f, of, then I have f of a, and then I know that this is going to be less than or equal to, right, there's some kind of n that's going to fall between them, like this. Okay, this is an output value. In fact, actually, let's make that blue. I made it red, but I'm going to want to make the input value red, so let's just make this blue. Okay, so it's an output value that's between those two. And we have, so this is true, and let's start drawing this before we write anything else. So I have one axis, I have this axis. And then this is perhaps my x-axis. And my y-axis. And then I have the graph of this function. So let me do this like this. Okay. And I have this A and this B. So maybe, who knows, maybe A is here. Maybe B is going to be here. Okay, so I have, looking at that, I have, right, so right here I have my f of a. I'll write that in a second. Oh, that happens to be there. It's okay. Okay, so that's my f of b. This is my f of a. Okay. And then I have some value n, right? This value n is between this f of a and this f of b. So I chose some value n that was between those two outputs. Okay. And the last thing I know that's true, and this is true over there, is that f of a does not equal f of b. Okay. Then I know. So if all three of these things are true, then I know that for some, so there exists, so there is some C that's in this interval AB, right, that's going to be satisfying, satisfying that, I'm not happy with this blue, but I have another one here. I feel like the blue is a little bit difficult to see. This one should be better. Right, I bet you like that one better. In fact, let's go over then with it. Okay, satisfying that we have f of c, so f of this value c is going to equal this value n. Okay, so that's going to equal this value n. So equal this value n, right, that was between f of a and f of b, right? So this value n here, we're going to be able to find some kind of c that's going to give that as the output. And it's okay if there's more than one. So looking at this, actually I have 3 that I can find. I can find going down from each of these. So I could say c. In fact, it's okay that there's more than one of these. You know, could choose any of these. It's okay that there's more than one. So could choose any of these, right? It's okay that there's more than one. Okay, so what does this theorem say? So first let's box it. Okay, and what it kind of says is that f is going to hit, so we would say that the way to kind of think of this is that f hits every value between f of a and f of b. So these are going to be f of a and f of b. Okay, and that's kind of how to think of it, is that if I have any value between f of a and f of b, then I'm going to be able to find some value between a and b, so that when I apply f to it, I do hit that level. Okay, I do get that output. Okay, so that's the intermediate value theorem that basically says that our way of describing continuous functions is correct. Okay, so I hope that made some sense, and I will see you in the next lecture.